Okay, for the topic of this video, we've got atoms and electrostatic forces, and atoms are like what makes up everything, and electrostatic forces are the positive force or the attractive force between a positive and negative charge. And we're mainly going to concern ourselves with attractive forces. There are repulsive forces in atoms, but they are not going to be the topic of this lesson. All right. So here's our specific objective. I would write that down for your notes. All right. Now, I want to talk first about hydrogen and helium. You'll notice here I've got one proton, here I've got two. So how does the addition of nuclear charge in this case affect the electrostatic forces? So and by charge, we're talking the protons goes up. The electrostatic forces also go up. All right? That would mean this here is stronger than this here because it's got two protons pulling on it, and this one only has one. You can liken it to two people lassoing the same horse. If two people are lassoing the horse, they pull it tighter, and that's kind of what's happening right there. All right? So as the charge of the protons go up, the electrostatic force between it and any electrons also goes up. Now, on this one, this is lithium and hydrogen. What's got greater electrostatic forces? All right? Well, here you'll notice it's a little bit different because lithium has two energy levels, and hydrogen only has one. So where are the greatest attraction? All right? Well, right here between this is going to be the greatest because there I've got three protons pulling on each of these electrons. Therefore, that's going to be the greatest. And the thing is, as you go this compared to this, even though this is only being held by one in a hydrogen atom, and here it's being held by three, the fact that this is further away, the electrons tend to become held less tightly because as the energy level increases, this is the distance increases, all right, the electrostatic force goes down, all right? Now to apply this to one atom, this is sodium. Sodium has 11 electrons. So 2, 8, 11. Where the electrostatic force is the greatest? Right here. Because you've got 11 protons and the distance is relatively strongest between this and this. All right, so dent, 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 dent. There'd be 11 lassos. Here, their 11 lassos are still happening, but they're getting weaker because the electrons are getting further away. All right. And the furthest one is really not held as tightly because it's even further away. And therefore, it's not going to be held as tight. So this is the strongest, then this one, and then this one. Just to recap, as charge, and this is protons, goes up, the electrostatic forces also go up, all right? But as energy level and distance go up, these forces go down, all right? Those are the relationships. And how it really means is that sometimes atoms will hold their electrons really tight, and other atoms will not hold their electrons as tight, and will make them more reactive or less reactive.